So we won't look at log functions at all for this test. But again, this is a good place to practice because you're already practicing exponential function graphs. This is simply the inverse. Remember the 3 points that we just found for our log function graph. Do you remember what they were? See if you can write them down here. You know, I never really memorize these points. I just write them in backwards from what I've memorized for exponential functions. I know that 0, 1 is on an exponential function graph, so I just write 1, 0 here. Remember when we looked at exponential function graphs, we looked at 2 parts. Well, we have the same 2 parts here. So each of these has our base of a, and then we have 2 restrictions. A is greater than 1, A is between 0 and 1. So just like we did for exponential functions, here we're going to let A equal 2. So we're going to graph the function log base A of log base 2 of x log base 2 of x. Our base is A. So if this is our base, we're going to put it into those key points. 1 over 2, negative 1, 1, 0, 2, 1. And we're going to remember that this time we have a vertical asymptote at x equals 0. For the second graph here, we're going to look at a equals 1/2. So we're going to graph the function f of x equals log base a, which is 1/2 of x. So this time our base is 1/2. Can you write down the ordered pairs for this graph? Back in week 2, when we looked at basic function graphs, I suggested you memorize key points for the graphs. I hope you can see that now for these exponential function graphs and these log function graphs, it's very important that you have these basic or key points memorized. Why don't you take a minute and graph each of these functions? So your graphs should look like this. And remember back to our exponential function graphs, when the base A was greater than 1, we had a function that was increasing. Again, when the base is greater than 1, we have a function that's increasing. And when the base A was a fraction between 0 and 1, we had a function that was decreasing. Again, we have a function that is decreasing. Those are the differences between those 2 graphs. What we want to look at now are the properties of our log function graphs. Can you take a minute and write down as many similarities that you can find between these 2 graphs? So you hopefully saw that they both have a vertical asymptote at x equals 0. They both have the same x-intercept at the point 1, 0. They both had the same domain and range. The domain is from 0, not included. We have an asymptote there, to infinity, and a range of all real numbers. Think about the domain and range of our exponential function. Do you notice that they just switched places? That's because these are both one-to-one functions. Remember, if we want to find inverse functions, we have to start with a one-to-one function. And these do start as one-to-one functions, which means they can be inverse functions of each other. And of course, they both have 3 key points that we've already mentioned, and I hope you've started to memorize. 1 over a negative 1, 1, 0, and a 1, with, of course, that vertical asymptote, and a is the base.